Okay guys, welcome to today's video. We're going to be looking at as 1J from the Year 10 textbook, and this chapter is all about simultaneous equations, specifically simultaneous equations using the substitution method. So there's no real way to sort of explain this other than really just jumping straight into it. So let's start off with question 1a here. And for question 1a, we have the two equations. Well, our first equation is 2x plus y equals 1, and our second equation is y equals x minus 5. Okay, and because we have this y equals thing, well, we can just put that straight into there for y. So what we're going to do is we're going to go 2 into 1, right? And then that's going to give us 2x plus, right? And then instead of it being y, it's going to be x minus 5 equals 1. We can therefore say, well, if we collect our like terms here, we have 2x plus x, which is going to give us 3x, and minusing 5, that's going to be equal to 1. We can then do good old reverse BODMAS and add 5 to both sides, giving us 3x equals 6. Then after that, what we're going to be doing is dividing by 3 in order to get x by itself, and we get x is equal to 6 divided by 3, which is 2. So let's slap a box around that. Now we need to find y, so we know x is 2, so we can put that straight back into equation 2. So therefore y equals 2 minus 5, and 2 minus 5 is neg 3. So y equals neg 3 there. Slap a box around that, and we are done. Okay, moving on to question 2 now. In question 2a, doing ESQ here, we have the equations. The first equation is y equals x plus 5, and the second equation is 3x plus y equals 13. Okay, well, using the substitution method, we can put 1 into 2. And then in that case, well, we would get 3x plus x plus 5 is going to be equal to 13 there, right? Because y is equal to x plus 5, and when we substitute that in for y, we get this. So then we, of course, collect our like terms. So 3x plus x is 4x plus 5, and that's going to be equal to 13 there. We can then, of course, subtract 5 from both sides, and we get 4x equals, well, 13 minus 5 is going to be 8. And then, well, 4x is the same as 4 times x, so if we divide by 4, we get rid of that 4. And we get x is equal to 8 divided by 4, which is 2. So let's put a box around that, and that is it for x. Then we can put that straight back into the first equation, y equals x plus 5. So therefore we could say y equals 2 plus 5. And of course 2 plus 5 is 7. So put a box around y equals 7. And that is done. Off to see the wizard now. And for question 2c, our first equation is y equals x minus 2. And our second equation is going to be 3x minus 2y equals 7. Okay, so again, what we're going to do is we're going to put equation 1 into equation 2 here. And then that would give us 3x minus 2 bracket, and then we would substitute in the y bit, which would be x minus 2. Yeah, so y equals x minus 2, but we've got to times it by 2 because we've got negative 2y here. And that's going to be equal to 7. So then we do a good old expandio brackets. Get 3x minus 2x. Minus 2x there, and negative 2 times negative 2, that's going to be plus 4 equals 7. 3x minus 2x is x, plus 4 equals 7. Well, then we would minus 4 from both sides to get rid of that plus 4, and x would be equal to 7 minus 4, which is 3. Then, well, we know that, so we can just straight up say that therefore y, like before up here, equation 1, y is going to be equal to 3 minus 2, and 3 minus 2 is, of course, y equals 1. So let's put a box around that, and that one is done. Okay, moving on to 2e now. 2e, and the equations that we have are, well, the first one is going to be y equals x, and the second one is 4x plus 3y equals 7. All right, so if we just substitute in y equals x into 4x plus 3y equals 7, well, so we go 1 into 2 there. Well, that means that we are going to get 4x plus 3x, because remember y equals x, equal to 7, and 4 plus 3 is going to be 7x equals 7. Divide both sides by 7,